we're on Calculus, Unit 7, Day 58, Part 3. I'm just going to set up some of these, and then we'll talk about them later, or you already have the solutions, but now I'm able to talk through them. So, given to the right is the graph of f of t. And again, whenever you get that, you should probably label it. And I look, where is that in here? But which consists of 3 line segments and 1 semicircle. Additionally, let the function g of x be defined to be g of x equals the integral of f of t dt from -1 to x. Okay, so 1 and 2 are find g of -6 and find g of 6. So at the end of these problems, we're just finding the area under the curve because it's the integral of f of t, and you're just going to put that in. But the first one has a little bit of a trick on it. When I put in -6, we never want to go from a number like -1 and go to a smaller number, -6. So I need to use my properties of integrals to take the opposite of that integral and change my interval. So now it's from -6 to 1. So you would look from here at -6 to -1, find the area under the curve, and then put the negative out in front. And again, this is all of f of t dt. Okay, but that's the first part you're doing there. Number 2, same thing. It's from -1 to 6. So now you go from -1 all the way over to 6. And that was fine. Okay, number 3, we're trying to find g prime of 6. So I got to first find g prime of x. Well, on this one, g prime of x, and we're going to use the second fundamental theorem of calculus, which says if I go from a constant up to a function, that I can just put it in. So it's going to be f of x, because that was the g of x, that's the function, times the derivative of that upper interval, which is just 1. So now I know g prime equals f of x, and now they want to know really what f of 6 is. So we're going to go and look at the function f of 6 equals 2. Okay, so they want to know what g prime of 6 is. This is just f of 6, and this is 2. And the same is true for number 4. So g prime of 2 equals f of 2, and this is equal to -2. Alright, let's look at the last two. Okay, so we're going to start with the information that we had from the previous problems, that the first derivative of g was equal to f of x. So when they want to know what the second derivative is, alright, well, the second derivative is just equal to f prime of x times 1 if I use the chain rule, because take the derivative of the outside, leave the inside the same, times the derivative. And so therefore, when they want to know, hey, what's the second derivative at 2, we're finding what the first derivative of f of x is at 2. And let's go back up to the graph. This is the graph of f of t. So when I come to 2, ooh, that's a corner, therefore it's going to be undefined. So again, undefined because it's corner or cusp, whatever you want to say. Number 6, same type of problem. Second derivative, we already did the work. So the second derivative of g is equal to the first derivative of f. And let's go up to where -4 is. Ooh, that's right here. So now I can just count this segment. I go down 2 over 1, so it's going to be -2. So they specifically want the second derivative of g. Okay, give a reason. So I know the slope of f of t. Slope of f of t is -2 at time equals -4. Okay, so there's one of the last problems. Okay, on this last page, I think people see the just that we're on the unit or a day that's dealing with second fundamental theorem of calculus. Remember, it's when I have g of x equals something with an integral, and this does have it. It has this function up top as the upper interval and 0 as the lower interval. So when I'm trying to find the derivative, and then I'll use it to help me find the second derivative, that's when we use the second fundamental theorem of calculus. When I'm just trying to find a value, I just substitute those values in. Okay, and this is the graph of f of t. So Alright, so let's take a look at these. So in the first one, every place C and X, we put in 3. 3 squares 9, half of that's 9 halves. Then they want to go from 0 to 3, so from right here to right here, I do the area under the curve. What I find out is that this triangle, which is above the x-axis positive, is exactly the same as this triangle. Therefore, they cancel each other out. So that's 0. And again, integral is the area between the curve and the x-axis. Above the x-axis is positive, below the x-axis is negative. So we just get 9 halves. So the same thing for the second one. So we place C in x, I put in -4. -4 squared is 16 times half. 1 half is 8. The problem I run into here is from 0 to -4, so I have to make it the opposite and then change my intervals because I'm taking the opposite. So from -4 to 0, and I have a couple quarter circles here. Obviously the bigger one is above the x-axis, so let me write these out. Okay, so now this has a radius of 1, so it's pi r squared. Obviously it's 1/4, and this negative right here is because it's below the x-axis. This negative out here was from when we switched the intervals. Okay, and then we have, oops, excuse me, my other quarter circle has a radius of 3. So let's now just simplify this. Well, this is going to become 9/4 pi. This will become -1/4 pi. And when we combine those, 9/4 minus 1/4 is 8/4, which will be 2 pi. So this is going to be 8 minus 2 pi. Okay, for the third one, every place that I see, no, excuse me, it's g prime of 3. Let's first find g prime of x. So for this part, I just take the derivative. 1/2 x squared, 2 times 1/2 is just 1. So it's just going to be x. Here becomes the second fundamental theorem of calculus. So it's a constant up to a function, so I can just put the function in. So it's going to be plus f of x times the derivative of the x, which is just 1. So the derivative is x plus f of x. So now I can put in 3, and I'll get 3 plus f of 3. This is just not looking for the area under the curve. That was the integral, which we just did on 1 and 2. This is just looking for f of 3. 1, 2, 3, come down. Oh, it told me that it was at -3. So this is going to be equal to 3 plus -3, and that's 0. Okay, and the last one, second derivative. So let's first do, what do I know? I know the second derivative. Oh, I didn't want to 2 yet. First, let's find the second derivative of x. Hey, derivative of x is 1, not 0. And the derivative of f of x is just f prime of x. If there had been something, and again, I'll put times 1, but if there had been something like f of 5x squared, you'd have to do f prime of 5x squared times 10x. You'd have to use the chain rule. So now let's do the second derivative of g at 2. The 1 stays 1 plus f prime of 2. So we're trying to find, so the 1 is a constant, but we're trying to find the slope of the tangent line at 2. So 1, 2, oops, this is a segment. So I'm at 0, 3, and I go to 3, -3, so I go down 6 over 3. It's going down to the right, so it's going to be a -2. So let's write that. So 1 plus -2. So this ends up equaling -1. Okay, so that is day 58, second fundamental theorem of calculus. Again, some of the confusion, when do I just find the area under the curve? That's when it's just g of 3 or g of -4. When do I do the second fundamental theorem of calculus? That's when it's g prime. And then I use that to give me the second derivative. Okay?